Hello students, this is my fifth videos on the concentration chapter solution, and the next concentration terms today is parts per million. This concentration term can be used when a solute is present in trace quantities. Now this can be defined parts per million in different ways: parts per million weight upon volume, parts per million volume upon volume, and parts per million weight upon weight. So parts per million weight upon volume equals weight of solute in gram upon volume of solution in ml multiply 10 to the power 6. Next, parts per million volume upon volume, that means volume of solute in ml upon volume of solution in ml multiply 10 to the power 6. And parts per million weight upon weight, that means weight of solute in gram upon weight of solution in gram multiply 10 to the power 6. Now I'm taking a numerical on parts per million. The question is, a sample of drinking water was found to be severely contaminated with chloroform, supposed to be a carcinogen, and the level of contamination was 15 parts per million by mass. So express this in percent by mass and determine the molality of chloroform in the water sample. So in this question, 15 parts per million, 15 parts per million, that means 15 gram of chloroform, 15 gram of chloroform, that means CHCl3 is present in 10 to the power 6 gram of solution. Fifteen gram of chloroform is present in 10 to the power 6 gram of solution. So 10 to the power 6 gram of solution contain 15 gram of chloroform. And 100 gram of solution will contain 15 upon 10 to the power 6 multiply 100, which will be equal to 15 multiply 10 to the power minus 4%. That is 1.5 into 10 to the power minus 3%. So this is a percent by mass. 1.5 into 10 to the power minus 3 gram of chloroform present in 100 gram of solution. Now the second term, determine the molarity of chloroform in the water sample. Now we have to find out the molarity. So for finding molarity having formula, molarity equals weight of solute upon molar mass of solute multiply 1000 upon weight of solvent. This is the formula for finding the molality. Now see the question. We have the mass of solute, that is 15 gram, and mass of solvent, we can take 10 to the power 6 gram. Mass of solute, that is chloroform CHCl3, it is 15 gram, and mass of solvent we can take 10 to the power 6 gram. The molar mass of chloroform, will be carbon, 1 carbon 12, 1 hydrogen 1, and 3 chlorine, 1 chlorine atomic mass 35.5 multiply 3, 12 plus 1 plus 106.5, so it will be equal to 119.5 gram per mole. This is the molar mass of chloroform. Now we can put the values in the equation. Molality equals weight of solute, that is 15 gram, molar mass of solute, that is 119.5 multiply 1000 upon mass of solvent 10 to the power 6. Now we can solve it. We can calculate it, so we can get the answer 1.255 into 10 to the power minus 4 mole per kg. Now I will talk about temperature independent concentration terms like percent, weight by weight, mole fraction. And next I will talk about molality. These are the concentration terms which are independent of concentration, independent of temperature, because they have mass, and mass does not depend upon temperature. So percent, weight by weight, it can be defined as the weight of solute in gram upon weight of solution in gram multiply 100. So this is the definition of percent weight by weight in weight of solute in gram upon weight of solution multiply 100. Next term is mole fraction. Mole fraction can be represented by X. Understand this term. Suppose we have solution in which two components are present, component A and component B. Binary solutions we have, and two components are there, one is solute and one is solvent. So in this solution, suppose you have taken number of moles of component A, Na, and number of moles of component B, that is A and B, and total number of moles equals to Na plus A and B. So we can define mole fraction of individual component. So mole fraction of component A can be written as XA, which is equal to number of moles of component A upon total number of moles. total number of moles, which is equal to Na upon Na plus Nb. And for second component B, mole fraction of component B, that is Xb, equals to number of moles of component B upon total number of moles, equals to Nb upon Na plus Nb. For individual component, this is the mole fraction of moles we have, and the sum of the mole fraction of the all the component present in the solution, that is Xa plus Xb equal to 1. Or if you find out the mole fraction of component B, so Xb equal to 1 minus Xa. Mole fraction is a unitless quantity because we have the fraction of moles, that's why it is a unitless quantity. Now the molality. Molarity can be expressed by small m, and it can be defined as the number of moles of solute present in per kilogram of solvent. That is called molality. So molality equals moles of solute upon mass of solvent in kg. This is molarity, or we can write mass of solute upon molar mass of solute and mass of solvent in kg, or mass of solute upon molar mass of solute multiply 1000 upon mass of solvent in gram. This is the molality. Now, relationship between mole fraction and molality. Relationship between mole fraction and molality. Mole fraction and molality. So we have the relationship between mole fraction and molarity. This can be related as mole fraction of solute equals molality upon molarity plus 1000 upon molar mass of solvent. This is the relationship between mole fraction and molarity. Mole fraction of solute equals to molarity upon molarity plus 1000 upon molar mass of solvent. Now I'm taking a numerical on that. Numerical is calculate the molarity of sulfuric acid solution in which the mole fraction of water is 0.8. So in this question we have the mole fraction of solvent, not solute. We know mole fraction of water and mole fraction of sulfuric acid. Two components are there, sulfuric acid and water. So here in this solution, sulfuric acid is solute and water is solvent. The mole fraction of water plus mole fraction of H2SO4. So sum of all the mole fraction of all the component equals to 1, and here we have the mole fraction of water 0.8. So mole fraction of sulfuric acid equals to 1 minus 0.8, which is equal to 0.2. We have the mole fraction of solute, which is equal to 0.2. So now we can apply this formula. Mole fraction of solute, that means xb equals to molality. In these questions we have to find out the molality. So molality upon molarity plus 1000, and we know the molar mass of water, that is 18. So mole fraction of solute we have 0.2 equals to m upon m plus 1000 upon 18. So 0.2 m plus 200 upon 18 equals to m. We can write it. So 0.8 m equals to 200 upon 18. So m equals to 200 upon 18 multiply 8 multiply 10, which is equal to 2000 upon 144. We can solve it. Now get the answer. 13.88 mole per kg. This is the molarity of the solution.